Today we are concentrating on unit number 3 of energy and change, unit number 3, which covers heat transfer. Okay, heat transfer, that is on page 243 of your textbook. Okay, so heat transfer is going to be divided into two subsections. The first one is heating, and the second one is ways in which heat is transferred. Okay, in our previous chapter, previous unit, we have talked about energy transfer. This time we are talking about heat transfer. Okay, so we start with heating. They say here, in winter, we all make use of the transfer of heat energy when we are cold. A heater or fire transfers the energy from a warm object to a cold object. This transfer of heat energy will continue until both objects reach the same temperature. Examples. Just before we go to examples, please note that a heat transfer always moves from a warm object to a cold object. Always warm object to cold object until both objects reach the same temperature. An ice cube in a glass, the example is an ice cube in a glass of tap water. Remember, ice cube will be cold and tap water will be a little bit at higher temperature than the ice cube. So which means that heat will move from tap water to the ice cube. The energy is transferred from the tap water to the ice cube. This causes the ice cube to melt and the water becomes a little bit cooler. The energy is transferred until all the water in the glass reaches the same temperature. Heat can be transferred in different ways. The first one is conduction, the second way is convection, and the third way is radiation. So heat can be transferred in three different ways. Number one, through conduction, through convection. Number three, through radiation. Now on the next page, now they explain in detail each and every heat transfer way. Okay, we start with conduction. You need to know the definition of conduction. Conduction is the transfer of heat energy between two solid objects in direct physical contact with another. Okay, so examples of conduction is a stove plate in contact with a pan. The stove is the source of heat and transferred the heat to the pan until the same temperature is reached all over. So we see the pan on a plate of stove. Second one, next step, a hot pan is placed on the table. The heat from the pan is transferred to the table. When the pan is lifted, you will be able to feel the warm spot on the table where the heat was transferred. So it's two examples, okay? And then materials can be divided into two groups. They can be good conductors of heat and they can be poor conductors of heat. Let's look at the good conductors of heat. Materials that conduct heat easily. Examples are most metals like copper, aluminum, and iron. And they can be used equipment like pots, pans, stove, plates, and the element of the kettle. And we have poor conductors of heat, which are materials that conduct heat slowly. For example, plastic, cork, ceramics, and wood. And those materials, they can be used for handles of pots and pans. On a quick fact, they say a material preventing or slowing down conduction is called an insulator. Okay, let's go through it again. A material preventing or slowing down conduction is called an insulator. Okay, now we move to the next page, which is page 246, and we look at the next Second way of heat transfer, which is convection. Convection is the transfer of heat energy from one place to another through the movement of liquid or gas particles. Okay, so they say air and water expand when heated. The particles of hot air or water move upwards, and when it cools down, it moves downward again. This is known as convection currents. And quick facts: convection currents can only occur in liquids and gases because the particles can move around freely. Okay, please know the definition of convection and know that convection can only happen in liquid and gases. The reason is particles can move around freely. Okay, and we continue. We go to page 248. They say, how is convection used in everyday life? Convection ovens distribute the temperature evenly throughout the oven, and more dishes can be baked at once. So convection is used in ovens, baking ovens, and then convection as well can be used. Water in a kettle is heated by convection, and also the lava lamps use convection. We have examples here of convection. The heat energy from the sun is transferred mostly through radiation. Okay, no. So this is not the example for convection. Okay, so we end here for convection. Then we move to radiation, which is the last heat transfer. They say radiation is the transfer of heat energy without physical contact and without movement of particles. The example, heat energy from the sun is transferred mostly through radiation. This type of radiation can move through empty space. The heat energy from a flame can be transferred through radiation as well. On the next page, 251, they say heat from the sun is transferred mostly through radiation by means of infrared rays. These rays transmit through empty space, which is the vacuum. The empty space is the vacuum, to the earth. Interesting fact, the infrared rays transfer the heat energy from the sun. Okay, and we page to our last page, which is 253. Page 253, they say different surfaces react differently to heat radiation. We are still under radiation. So dark surfaces, the heat is absorbed and the surface heats up quickly. But for light and shiny surfaces, heat is reflected. Dark surfaces, heat is absorbed. Light and shiny surfaces, heat is reflected. Okay, the surfaces do not heat up as quickly as the darker surfaces. And that last paragraph, they say how radiation is used in everyday life. Black and dark colored vehicles are used in colder countries like England. Oh, I didn't know this. The vehicle will then be warmer inside. Okay, because that color will absorb the heat and the surface will heat up quickly. And then solar panels are dark to absorb as much heat as possible. And then in hot regions, houses, even roofs, are usually painted white to reflect as much heat as possible. The house will then be cooler inside. And then light colored clothes for summer is cooler than dark colored clothing. Okay, because dark surfaces or color objects, they absorb heat and they heat up quickly. So it is rare that in summer you will find people wearing blues, navy blues and blacks. Okay, because they will make you warm. So you rather wear light colored clothes. Okay, because they are cooler than dark colored clothes. So these are the everyday use of radiation. And this brings us to the end of unit number 3, which talks about heat and heat transfer. With that said, you can do activity number 7 and exercise number 3. And don't forget to look at your summary and your mind map.